Hey everyone, in this video we're diving into HyperBEAM, a distributed computing framework built on Erlang OTP that powers modular, message-driven computation. Let's go over what we'll cover today. We'll start by breaking down what HyperBEAM is and how it works, including the Converge protocol and the concept of virtual devices. Then we'll walk through a hands-on example, building a calculator device that performs basic math operations using a combination of Erlang and native C++ code. Finally, we'll compile the project, run tests, and explore the code that makes it all possible. Whether you're new to distributed systems or looking to extend HyperBEAM with your own custom logic, this tutorial will give you a solid foundation. Let's get started with a few key ideas. In HyperBEAM, a device is a virtual module, not a physical object. It is a lightweight process that can receive, handle, and respond to messages. Devices are how HyperBEAM structures distributed computation. You can think of them like mini servers or microservices, each handling specific types of logic. The calculator device we're building is a demonstration of how to use Erlang and C++ together. It takes math operations like add, subtract, multiply, and divide, processes them using native code, and returns the result, all via structured messages. Now that we have some background, let's go over the Getting Started with HyperBEAM article published on mirror.xyz. A link can be found in the description of this video. HyperBEAM is a message-based distributed system designed to support device-level computation. It's built on Erlang OTP and uses something called the Converge protocol to orchestrate logic across devices. The GitHub is linked here in this article. The app is configured through this application definition file, which declares the modules, dependencies, and core settings. Think of it as a blueprint that holds the whole system together. HyperBEAM uses Rebar 3 as its build tool, which manages all compilation and dependencies for Erlang and native code. The Converge protocol is the core logic path for devices. It handles message resolution, validation, native execution, and response formatting. Every device interaction runs through these four critical phases: initial resolution, message validation, device execution, and result processing. This standardizes how devices talk, reliably and efficiently. Now that we have some background, let's build a simple device on HyperBEAM. To build the device, we added a few things behind the scenes, including C++ logic, Erlang interface files, and a small config tweak to register the device. But don't worry about that for now. First, you need to make sure you have all of the necessary dependencies installed. They can be found at this link on the PermaWeb HyperBEAM GitHub. You simply go through each of these tabs and copy the commands into your terminal. Now that those are installed, let's build the device. First, we clone the Apis Network HyperBEAM repository found at the bottom of the article. Then, we navigate to the HyperBEAM project folder. Next, we make sure we're on the correct branch. Now we can compile everything. I sped this section up because it can take some time. Lastly, we can just run a simple test to make sure our calculator is working. If you see tests passing like this, congrats, your custom calculator is working. Let's take a brief look under the hood at the files we added to make this all possible. All of the files can be found in the Apis Labs HyperBEAM GitHub located here. There are 5 key files. This file, hbopts.erl, is where we registered our new calculator device so HyperBEAM knows to load it at startup. You can see that here. devCalculator.cpp is the core logic for the calculator. It handles the math operations add, subtract, multiply, and divide. devCalculatorNIF.cpp connects the C++ logic to Erlang through a mechanism called an NIF, or Native Implemented Function. devCalculatorLog.cpp is a simple logging utility that helps track operations and debug behavior. devCalculatorNIF.erl is the Erlang wrapper that directly calls the C++ code via NIF. And lastly, devCalculator.erl is the Erlang side logic that defines the device behavior and how it communicates within the system. These components work together to create a full-stack device that bridges native performance with distributed communication. That wraps up our walkthrough of HyperBEAM and how to build a custom calculator device from start to finish. We covered what makes HyperBEAM unique, including its distributed architecture, the converged protocol, and the concept of devices as lightweight, message-driven modules. You saw how we combined Erlang and C++ to implement real computation, register our device, and successfully test it inside the system. Whether you're building a calculator, a machine learning module, or something entirely new, HyperBEAM gives you a modular foundation to build on top of decentralized infrastructure. If you found this tutorial helpful, check out the full article on mirror.xyz, linked in the description, and follow Apis Network for more guides, developer content, and ecosystem updates. Thanks for watching, and see you in the next build.